Welcome to question 3 of the 2018 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 3 we have let f be the function with the domain of 0 to 2 pi, where f of x is equal to 2 cos of x plus 1. For part A we want to solve the equation 2 cos of x plus 1 equals 0 for x is between 0 and 2 pi. So if we're solving 2 cos of x plus 1 equals 0, that's the same as solving cos of x is equal to, and subtracting the 1 first and then dividing by 2 gives negative a half, which is related to exact values on our unit circle. So if we bring up a unit circle, we know that cos is read off the x-axis, and cos of x equaling negative a half is back here. So we need the angle that is related to pi on 3 to get that. So if this is 3 pi on 3, then we take pi on 3 to get to there, and we add pi on 3 to get to there. And they are the two solutions between 0 and 2 pi that satisfy this equation. So therefore our answers are x is equal to 2 pi on 3, or x is equal to 4 pi on 3. So that is the answer to part A of this question. From the examiner's report we can see that 72% of students got full marks for this, and that the examiner goes on to say that this question was well answered. However, some students gave solutions beyond the given domain, or incorrect values, often confusing pi on 6 with pi on 3 as the required reference angle. For part B, we want to sketch the graph of the function f on the axes below, and we need to label the endpoints and the local minimum point with the coordinates. And now, just importantly, we need to note that 0 to 2 pi is the restricted domain for the graph, and that is shown on the scale of the x-axis too. Now, if we think about this from a transformations point of view, we have the graph of y equals 2 cos of x would just look like this. So this would be 2 cos of x. So that means that 2 cos of x plus 1 would look something like this. And we know in the previous question we solved 2 cos of x plus 1 equals 0, which is the same as finding the x-intercepts of the graph. So we know that they go through 2 pi on 3 and 4 pi on 3. We know that when the graph was not translated, it went between 2 and negative 2, and that now the graph will go between 3 and negative 1. So using all of that information, we know that this is a endpoint or a starting point. This is the ending point up here, and we know that the graph reaches a minimum at negative 1 and that it's symmetric, so it will lie at pi. So the graph therefore is going to look something like this. You'll also note that the graph does in fact pass through these points here, so it's important to be accurate when we're sketching our graph. Now, just before we finish up, we need to label those points with the coordinates that were asked for. So this endpoint is at 0, 3, and this endpoint is at 2 pi, 3, and this minimum is at pi, negative 1. And now it didn't ask for the x-intercepts of this graph, but they should be shown where the location is accurately. So from the examination report we can see that 66% of students got full marks for this, and overall this question was well answered like part A. And even students who made little progress in part A were still able to attempt this problem. Some students did not label the 3 key points as directed by the question, or drew graphs with more than one cycle, so they didn't consider the domain. Students who took care with the shape, especially the endpoints, and those that linked their answer from part A to this question, so part B, were generally successful.